Hi, my name is Eric Dewar. I'm Associate Professor of Biology at Suffolk University in Boston, and there I teach a class about evolution for students who don't major in science called Humans and the Evolutionary Perspective. I'm here today with a couple of my honor students where we're going to talk about some articles that we read about mental disorders and evolution and how we can use this as a framework for understanding things about human diseases. Well, first, why don't we introduce everybody?
Hi, I'm Jordan Smith, and I am a freshman at Suffolk studying sociology with a focus in crime and justice.
Hi, I am Katelyn. I am a sophomore at Suffolk, and I'm studying broadcast journalism with a minor in public relations.
Right. So one of the things we read was taking kind of a comparative approach to understanding how, like, what the prevalence of different diseases is like. So comparative approach meaning we're looking at other kinds of mammals or other kinds of vertebrates, like what kinds of disorders they get. And particularly this one about like why animals don't get schizophrenia. They're like, because we do see certain kinds of like obsessive compulsive disorders in animals, particularly for zoo animals. So yeah, what do you want to start with talking about this?
Well, to start off, when me and Jordan had originally picked this topic, it was something that was really interesting to us because we're like thinking about a lot of different, in class, talking a lot about mental disorders and different things. And we were like, why don't we see a lot of the similarities that we see in humans versus animals? Now we see a lot of different ones about like self-mutilation and anxiety that we'll talk about. But we're like schizophrenia, and there's some really like higher level mental disorders that we're like, why isn't there a connection? Where is this bridge? So that's kind of what our article talks about to kind of start it off. And we looked at the idea of maybe higher order thinking and like complex mechanisms in our brain leads to complex malfunctions. And that's kind of how we got started off into our schizophrenia article.
Mm-hmm, mm-hmm.
Yeah, the article talks about HARs, which they're related to the way that humans evolve. So like HARs help humans evolve quicker. And those they discovered were like close to schizophrenia genes on the genome. So they decided to see if that had any correlation, which they found out it did.
Mm-hmm. If I could just throw in
And
for
that
a
also
second.
related to GABAs,
Yeah, if I would just throw in
which
for a second
also
here.
relate to high order thinking, which I found very interesting. And
Okay. No, I hear you. No, definitely. I just
yeah,
want to throw in the HIRs. Those are what are called human accelerated regions. They're parts of the genome that seem to have really fast evolution compared to other parts, or at least really fast mutational change. And what Jordan was saying is, yeah, we see them close, like geographically close on the genome to some of these genes that are related to GABA expression, which is a neurotransmitter. And they probably have some kind of regulatory association with them. So mutating fast, but also it's not causing effects just for those genes, but for the way that they regulate other genes. Yeah, totally. And this was the Iceland one, right? It was kind of an insular, pretty genetically homogeneous population, so they were able to kind of knock out something useful on it. Yeah. And what else were you going to put in about that?
so these genes were found in the prefrontal cortex, which has to do with this decision making, and that also was associated to the schizophrenia gene as well.
Mm-hmm. So yeah, they get expressed principally in places like the frontal cortex, where like a lot of planning kinds of
Yeah.
behaviors happen, and that actually develops later in life than other parts of the brain do. Yeah.
And going with the prefrontal cortex as well, one of the doctors, Dr. Joel Dudley, had a quote in there, and he was talking about that they think that schizophrenia risk is associated with intelligence. So that's why they were saying that we probably don't see it as much in a lot of animals. And it was really interesting to hear that when we broke away from primates, they resulted in the genomes evolving rapidly. So we have a lot more abilities that other species lack. So I thought that was really interesting to see that schizophrenia is really related to, in a way, the idea of like a really complex, higher order of thinking, like a meaty brain per se, to see that with so many different activities and complex ways that the brain operates, it also comes with a lot of malfunctions that we see, sadly. It's a give and take, it sounds a lot like.
Hmm. First of all, I'm going to be that guy to say we didn't break away from primates. We're related to primates, but I get what you're saying when we shared a common ancestor with other non-human primates. This is like particularly thinking about, was it speech as well? Was the one of the
Yep.
centers that they talk about? So like Broca's area, these other brain modules that are associated with particular kinds of functions. Yeah, as there are these new areas, like new like geographic areas of the brain getting dedicated for particular functions, we start to see these, the effects of these, of how mutations in these other genes are going to kind of map onto it. And yeah, and it's complicated. Like anything, any complicated system can get messed up in a whole bunch of different ways. So I think that's this is a classic story of that, because it's the brain's complicated to build. It grows in response to stimuli that it gets before birth and after birth. And in humans, your brain, your prefrontal cortex in particular, doesn't stop really, doesn't really complete its main part of its initial formation until you're in your 20s for most people. So there's and I legit feel that there are times when I think when I was going to, you get like these intrusive thoughts. It's like, oh, I should do this thing. Then like I find myself, thinking, well, but if I did that, then something else would happen. So the ability to plan actually really does change as you get older. But I was like in my 40s before I started thinking like that. So maybe this is me.
I
But
also found it really interesting that there's like a really big debate in science going on as well about evolution versus like more of like the sociological sciences and human behavior, and that there's kind of like a fight going on a little bit about how human behavior relates to evolution versus nature versus nurture and what we learn. So that kind of also went into the articles as well. So that was kind of interesting to know that there's a little bit of like divisiveness in the field right now about how we look at evolution versus how we study human behavior in the social sciences as well.
yeah, Jordan,
Yeah,
what you thought about that?
with that, I was gonna relate the higher order genes like having a beneficial trait as well as like the sacrifice of like schizophrenia or other mental disorders. And in the topic of with sociology relating to evolution and like anthropology and evolution, in the second article, it talks about how maybe genes and like mechanisms in our brain that helps with reproductive success and survival in the past evolved, and now there's things that came with them that are seem negative to us, but really maybe in the past they were ways that they had to survive because of like different circumstances, different environments, different ways of life. And now we see them as negative. They relate like specifically like the sociopathic gene, like could have that have been something beneficial in the past? Now it's seen as something negative, maybe.
Hmm. Yeah, genes. I mean, not just genes, like the behaviors that these genes
Right.
facilitate happening, um, actually, um, being previously, I think they said being previously under like weak selection before, there's a big fitness benefit for, increased social behavior, pro-social behaviors, but they drag along with them some things that, some ragged edges as well. Um, there's something else I was going to qualify what you said. I don't remember what it was. Anyway, the yeah. So actually, getting on to that, so we it also, one of the other papers, and I've actually never read a paper out of aggression and violent behavior, that journal, before. Um, I have done reading elsewhere about how brain, the way that brains are, the way that brains bring in propensities toward some pro-social or anti-social behaviors. It's not only about having a lot of testosterone. It's like there are things that happen in the seconds before a behavior. There are things that happen in the years before a behavior. There are things that happen like over evolutionary history to kind of develop this brain that's going to end up eliciting this behavior. So there are like a lot of like scales of magnification we can look at with them. But let's talk about that. The other paper we read about, looking at differences in, basically the way that we can use evolution as a as like a as a framework for understanding, or like for a way of thinking about these different kinds of antisocial behaviors like crime.
When I first saw it, I was put off because I thought to myself, like, how does the first article really relate to like criminal behavior? But the more I read into it, I understood the idea that we're struggling with how does evolution play into this, and how much of this is just people who are kind of like who have really high testosterone about male on male violence and stuff like that. And it seems that these mechanisms that were successful for survival in the past that evolved over time, we see them as like specialized mental organs now. And it's kind of interesting to see the idea that there's a big debate. Like I said before, there's a really big debate in science, and we kind of have to decide what is an adaptation because of evolution and what is a byproduct of these adaptations, and what is something that maybe is on an individual basis, a person by person basis, versus what is evolutionary and has been adapted to fit today's society.
Yeah, Jordan, what
And
would you
it's
say about it?
the whole topic is somewhat controversial because people in like the sociology field will argue that it can excuse certain behaviors that otherwise aren't excusable, such as like murder or rape. These could be pushed off to say that they are helping reproductive fitness or helping survival. And that brings a big topic of debate whether like that should be used to excuse something like that, or not even excuse, to even be in the background for it.
That reminds me of the video we watched in class about does science inform morality? And the idea, my personal belief was that I think science gives everybody an understanding, and then from that understanding, they make their own moral decisions. I don't know if science really should um, give morals. I think it's more that science provides greater context to an issue, and then from that issue, you take your moral viewpoint. So maybe for some people, I don't think that science should excuse criminal behavior. I think it should just be able to shed a light on it. And then from that, people can understand it better and make their own moral decisions.
Yeah, I mean, I think that one of the things that science is good at is naming things. And when we can name a thing, we can identify an idea. And when we have these ideas, when we have things that are named, then we also have, now we have something we can observe and something we can measure. So I think you're thinking about this is right, Caitlin, in that, we can, science doesn't tell you, we're not here to tell you how to live. On the other hand, we can, it allows us to set up a system where we can be sure we're talking about the same thing. And then we can, if we want to use different criteria for not excusing, but for for doing sentencing recommendations, that's going to allow us. We can do different things if we are taking, if we're getting a fuller context. It's not that but I think that, of course, this is going to be controversial. There are some kinds of crimes that we're going to think are going to be equally inexcusable regardless of what a person's background is. But that's still, but if we're looking at the great majority of crimes, which are kind of less serious ones, then what place do we have to be able to say, well, let's think about how what was not want to say wrong in somebody's upbringing, but what kinds of deficiencies would they have had in access to resources or in family support when they were growing up that are going to make them more likely to have this happen. I mean, do you think this should feed into? We actually talked about this in a podcast I did with my class last semester, but yeah, how do you think? Do you have a sense of like how you think the what a person's background is should feed into sentencing recommendations?
Um, I believe that it could help sentencing in a way of not like like a length of a sentence, but what the sentence is, because maybe if you know someone's background, you can have a different way of helping them. So you can take the science behind it and like use it to help them rather than to like make an excuse or to make it like seem less punishable. So if someone had a different background that maybe this seems that they could be like hated or like rehabbed to make them to come out and make them a better person, that could be a way of changing sentences rather than like saying the length or the seriousness or punishment.
Hmm.
I think there's something I just find something about science so interesting is you start on one topic and you always end somewhere else because they all connect somehow.
Yeah.
But
Yeah. Everything in the universe is connected to everything else. Yes.
I think it's really interesting to talk about the idea of like that person's background and upbringing or even their mental health. We see every time mental health gets introduced into like sentencing or something with that in the prison system, it's always odd. Something always happens. People don't understand it. So I think it's really interesting the idea that we can study maybe the evolution or the adaptation somebody has and then put that into our modern day world to show that like science actually does play a really important part, not just eco geographically or with different like rocks and animals and specimens. It has real life applications and it really does have a large effect on people's life, especially if you're getting sentenced for a really serious crime.
Mm-hmm. Mm-hmm. Which is, an argument for why it is, everybody's college has a gen ed requirement to do a science class. It's not this thing you got to do because we're looking for work for professors, but because, yeah, this is, you want to have, you want to be able to have this in your toolkit for the way that you think about stuff. Um, yeah, our time is getting a little bit short. What are some like last things you want to make sure we talk about before we close?
Interesting. I just really enjoy the idea of that somehow applying evolution is not stationary. And I feel like when we learn about it when we're really, really young, evolution is something that's like here and then everything else is over here. Evolution is like, this is what happened and that's it. And I find it really interesting that people are saying, wait a second, how does evolution influence human behavior and the social sciences? Evolution is not a standalone thing, it affects every part of our life. So, how is that affecting things specifically like criminal behavior and different mental disorders like how does evolution play a larger role in that and connect us back all in different ways back to the idea of that we've all evolved from a common ancestor, and from that a lot of different things in our everyday life are connected to it.
Yeah, so many. I mean, E.O. Wilson. One of the things he said was that famous evolutionary biologist said that many things are better understood knowing their history than their logic. And I think particularly when we're looking at our brains, because they are structures that have a history to them, they're not the way that you would have designed them. They're this weird kludge of of structures that got kind of mashed together because of competing, like, yeah, fitness benefits. Yeah, Jordan, what kind of ideas would you want to close with, or other stuff from the reading that you want to make sure we hit on?
I definitely agree with Caitlin. I'm a sociology major. I'm still a freshman, so I'm still in the early classes, but I've never thought of it as like in an evolutionary approach. I've thought of it like with the mental aspects, but never like looking back at where these things could have came from or why it's like that. So I think that was very interesting as well, how they discussed like there's three different approaches and they all can complement each other. And I never even heard of any of them. So reading this was very like insightful for me and interesting.
Yeah, and you're gonna be able to bring the heat on this with your papers that come with your papers and the rest of
Yeah.
your major, and
Mhm.
yeah, well, that is why perspective is in the title of this class. So, all right, well, good job, guys. Why don't you say thanks for watching for everybody?
Thanks
Thank
for
you for
watching.
watching.